Good morning, I am Paolo Bussotti and from Livorno, Italy, I would like to greet all the participants to the Symposium Science and Technology Education, Engaging the New Generation. The subject Science and Technology Education is fundamental to guarantee the development of any society. At the same time, the plurality of approaches and methods used to teach science, technology and mathematics in different countries as well as in different schools and universities within the same country is an evidence which testifies the difficulty of this subject. By the way, the numerous papers appearing in Journal of Baltic Science Education and in Problems of Education of the 21st century represent a quite good witness of this variegated and complex situation. Therefore, a further reflection on these problems is certainly useful. I am sure that this symposium will be a fruitful occasion to add new insights with regard to science education. Thus, I think your work will be precious. At the same time, I have no doubt that these 3 days will be for you days dedicated to the work, but to enjoyable activities too. And I am sure you will enjoy Vincenta's organization. Because of all these reasons, I am sorry that this year was for me impossible to join your meeting. I hope next time. I wish all of you a pleasant stay in Šiauliai and hear you soon. Have a nice time from Paolo Bussotti. Bye bye.
think so. Because it's leverage. When centers go, you go do it. Do it with Vincentus. I can't do it. Oh, Vincentus. How it works? I think so. Because it's leverage. When centers go, you go do it.
Hello, everybody. Very nice to meet you. Even though through the video tape, the presentation we are going to give today titled Influence of Nanotechnology Related to Socio-Scientific Issue Program on Competencies of a High School Student in Korea. The presenters are myself, Hae So, and Hae-suk Lee, Sunok Kim from Busan National University, Korea. A changing, interdependent, and conflictual society today demands education reform. School subject-bound curriculum barely prepares individuals to function well in such cases facing the present and future challenges. Individuals are not well educated to lead a successful and responsible life in contemporary society. OECD program initiated to equip students with a new skill and competency. Such a competency includes using tools interactively, interacting in heterogeneous groups, and acting autonomously. Further, the PISA 2015 especially scientific inquiry includes explain phenomena scientifically, evaluate and design scientific inquiry, and interpret data evidence scientifically. On the other hand, science education increasingly focused on socio-scientific issues, and society will benefit if science education encouraged students to adopt more positive and realistic view of science. In the similar context, science curriculum in Korea adopted competence-based curriculum in 2015, including scientific thinking ability, communication ability, and others. However, a few programs adopting competency-based curriculum in Korea, their effectiveness has not yet investigated. On the other hand, technology in our contemporary society is rapidly developing and continuously changing, and new technology keep producing new items in the market. In this context, individuals are required to have appropriate ability, attitude, and competence in science to reach solutions. In this study, we aim to examine how a nanotechnology-related SSI program influence on competencies of high school students in Korea.
Research questions. Has the program influence on students' competence of use tools interactively? Second, program influence on student competence required for scientific inquiry. Third, influence on student competence interact in heterogeneous groups. Research subjects include 30 students, 10th grade, 9 females and 21 males, from two high schools, Busan, Korea. Survey instrument consists of 50 items, 5 Likert scales, 5 items for each competency. Semi-structured questions about program effectiveness. Each student was interviewed for 20 minutes after program. Survey instrument items. Procedures. Analyze competency and then extract competency element, and program development and implement, and collect data and analyze. Program overview consists of Part 3. Part 1. What are the Steve Nano washing machines? And Part 2. Let's test their antimicrobial effects. Part 3. Buy or not buy. Part 1 focuses competence using tools interactively. Identify appropriate information sources from Internet database. Students recognize and determine what is unknown. We need to know both. After gathering information from website and other sources, students prepare to present to the whole class. Teacher present images of silver nanoparticle, And the student investigate the silver nanoparticle with the need to know board and choose one of different interest groups as stakeholders. This picture shows part 1 learning activity. Part 2 focuses competency required for scientific inquiry. Student questions in antimicrobial agent inquire how to use claims. Students have an opportunity to have in-depth discussion about valid experimental designs. Part 2 recognize the problem, formulate the hypothesis, design and perform experiment, and analyze data and draw conclusions. This picture shows the Part 2 scientific inquiry. Part 3 emphasizes the competency interacting the heterogeneous groups. 4 instructional strategies of this part: a role-playing debate and the jigsaw model. Students in a group were given one of 5 roles. Each group of students present a recommendation based on information and argument. Jigsaw model is present problem, situation, and role. Discussion 1, group activity in the same role. Discussion 2, group activity within 5 different roles. And group presentation of positions adopted during discussion 2. This picture shows Part 3 jigsaw model.
For the result, does the program influence on students' competencies of use tools interactively? We found that significant increase in students' competencies of using tools interactively. From interview, student told, "Is a silver nano washing machine expensive?" I checked the internet. There are cheap and some expensive washing machines. When I looked at other data. Research question 2. There was significant increase in students' competencies required for scientific inquiry. Student told, "I remember doing experiment with silver nanoparticle." Another student, I conclude from experiment that silver itself is not a carcinogen. Further research question 3. There was no significant change in students' competency of interact in heterogeneous group after program. Student told, "It was good to take the role of each and understand the position of other interesting groups." Another student, "I enjoyed explaining various aspects from social, environmental, and scientific viewpoint." Finally, conclusions. Nanotechnology-related SSI program influenced on students' competencies of use tools interactively, and PISA required from scientific inquiry, but do not influence on competencies of interact in heterogeneous group. Our suggestion in instructional strategy for part 3, interesting in heterogeneous groups, may be needed to reorganize for student deeper reflections on different interesting groups. Thank you for your attention. If you have a question, let us know. Thank you.
Hello Europe, hello Lithuania, hello Šiauliai, and Dr. Lamanauskas, hello all colleagues, the educational researchers. I'm going to present today about chemical eponyms in the epoch of educational ethnocentrism. Eponymy is a word of Greek origin made up of epi, over, and noma, name. It means giving name to something or naming after something or somebody. Eponyms are word combinations, often scientific terms, denominating a phenomenon, a law, a theory, a principle, an invention or procedure with the originator's name. Term eponym is more scientific, but there is another term more understandable, named something. For example, named reactions, named laws, named effects. Even though this term is widely used for particular items, the generic two-word combination named notion is rare and misleading. Eponyms are abundant in science and technology, in medicine, in geography, as you see them being scrolled here. Moreover, they are smartly played around in marketing. Here's what I saw in our local store. When browsing fruit on shelves, I ran into an Italian chemist Amedeo Avogadro's portrait on a pack of avocados number. By this time, eponyms have been well inventoried. There are books on chemical eponyms, medical, physical, geographical, engineering. Perhaps the most ultimate is this book of 1977, Eponyms Dictionaries Index. It comprises about 20,000 eponyms. However, as we will see, even this edition is not exhaustive. Eponyms are researched from sociological, linguistic, and what is important for us, from pedagogical perspective. Addressing eponyms in science education, Govinda Rajan and Rao mention anecdotal and historical merits of eponyms and argue learning of eponyms in science education can significantly enlighten the motivated as well as the disinterested student to embark upon diligent and productive endeavor in education and to relate the knowledge to present-day life and society. Eponyms possess two pedagogical potentials, didactic and axiological. The former is obvious. Students should study eponyms just because they are part of the subject. Being a form of shorthand, they make professional communication easier because specialists quickly recall their content and understand the subject. What is amazing, and we showed it in a recent publication, eponyms, and not only chemical eponyms, can be characterized using the same theories as molecules are characterized, valent bond and molecular orbital theories. Eponyms form when relevant information about the discovery and its author overlap nicely, thus creating a bonding orbital. Stability of the two-word system increases, internal energy lowers. So one can prove eponym formation with thermodynamics. The latter potential, axiological, lies in introduction of values. With teachers' initiative, every eponym can be unwrapped either into a fragment of the scientist's biography in the context of his discovery or into details of his discovery, flavored, humanized with the scientist's personality. Through eponyms, teacher can convey important values to students. The axiological approach puts up a principle of humanization in education. which implies that along with subject knowledge, educational task should include additional information on human activity in various aspects, such as history and art. This principle of humanization in education, as well as another good principle of historicism, is either manifested as such or present implicitly in many national documents governing education, including, say, US National Science Education Standards of 1996 and the US Next Generation Science Standards of 2013, Belarus Concept and Standard of Chemistry as a Subject, year 2009. This is why we address this topic, since eponyms, with respect to their didactic and axiological potentials, are a part of history of science, and teaching eponyms is in line with humanization and historicism. Reviewing literature for a dictionary of chemical eponyms, 106 sources in Belarusian, English, Latvian and Russian languages, 1,642 eponyms were identified, including named assets, adapters, apparatus, bases, catalysts, condensers, and so forth. Among the reviewed sources, one published in 1959, focusing on teaching chemistry, looked unusual. It mentioned 6 eponyms named by the author of the book. The author is an outstanding authority for teachers in the post-USSR countries. He really himself invented, developed, advanced and checked a number of experiments and devices. Some of them saved his name in theirs. So, not to question Verkhovsky's authority, but to check current usage and longevity of his eponyms was our research goal. To achieve this goal, we analyzed the book in question and searched on the internet for Verkhovsky eponyms, verbatim, in Russian and English using such services as Google Scholar, Google Books, databases EBSCO, Academic Search Premier, Web of Science, eLibrary.ru, and others. The book mentions 6 eponyms and contains images of 5 of them. Verkhovsky's Buret, Verkhovsky burner, Verkhovsky clamp, Verkhovsky audiometer, Verkhovsky stand, Verkhovsky ozonator. Ozonator is mentioned on the page next to audiometer but not described. What are the results? The internet search revealed the following eponym occurrences.
Verkhovsky Buret, 0 occurrences verbatim, 52 other occurrences, including publications by Teleshov, Kutumov and Stopin on laboratory techniques, listings of Buret along with other glassware. Same text in the following context. Sure enough, there are not all chemical devices. In our article, we did not mention Devi lamp, Renault picnometer, Verkhovsky Buret. On query Verkhovsky burner, the search engine returned the same publication by Stopin 2 times. The phrase Verkhovsky burner consists of 2 tubes. Verkhovsky clamp finds itself on the internet only once, in the book by Goryachkin, a physics methodologist, Verkhovsky's contemporary. Verkhovsky audiometer occurs on the internet 6 times, including publications by Fadeev, Zlotnikov and Teleshov. Characteristic quotation here. Till nowadays one can hear in school practice Verkhovsky audiometer. Verkhovsky stand occurs on the internet 29 times, including the earlier quoted quotation by Fadeev, Zlotnikov and Teleshov. On query Verkhovsky ozonator, its description is missing in the first volume of the book but is present in the second. We have 6 mentions, including publications by Fadeev, Zlotnikov and Teleshov. The same characteristic phrase, till nowadays one can hear in school practice Verkhovsky ozonator. Besides those mentioned in the book, there are also Verkhovsky test tube, 6 times. Verkhovsky Sazonov test tube 4 times. Here we see publications by Fadeev and Teleshov, but also listings from internet shop where one can buy the test tube. Verkhovsky apparatus 6 times. 5 of the 6 sources contain the same text. If the funnel in KEEP apparatus is broken or missing, one can utilize Verkhovsky apparatus. One source that is dissimilar describes a different Verkhovsky apparatus. There are 2 of them, one for gas generation, another for liquid distillation.
So all these findings relate to the virus entered into Google in Russian. As for those typed in English, even in multiple versions with respect to variability of using possessive case and transcription from Cyrillic script, Verkhovsky, 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 Verkhovskis, 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 no traces of the eponyms were found. Moreover, there appears only one page where the scientist himself is described in English. That's Russian Information Network. So, our search revealed that Verkhovsky eponyms do not occur in modern internet publications as applied to current laboratory practice or teaching chemistry. They are sometimes mentioned in the Russian segment of the internet as a historic legacy of the great Soviet chemist. Why aren't Verkhovsky eponyms mentioned in English internet? Well, one should understand that eponyms do have their fate. They arise, live their active life, may undergo transformations, often unpredictable, may drift from one country and domain of usage to another, may be even banned, may become less and less used and finally forgotten. Scientific eponyms popular in one country are not necessarily welcomed in another country. To illustrate, let us consult this dictionary. The person who has been eponymized the most was French chemist Georges Denisger with 80, just imagine, 80 phrases, including Denisger's microtest for novocaine and Denisger test for uric acid. And there are Denisger's eponyms in Russian chemistry too, for example, Denisger reactions, but not 80. Carl Friedrich Gauss, a German mathematician, is listed in this dictionary with 56 eponyms. Can a math teacher in Russia or Lithuania or Poland name them all? By the way, Jesus Christ here has 45 eponyms, only, same as Isaac Newton. Meanwhile, such Russian chemists as Zimin reaction, Butlerov synthesis are missing in this edition. It references only English sources. So no wonder that Verkhovsky eponyms are or were in wide use in Soviet Russian chemistry but unknown in modern English chemistry. Finally, as it were Russian Soviet inventions, it is not surprising to see an extensive usage of Verkhovsky eponyms in Russian language chemistry compared to other languages. The second question is how come that Verkhovsky's book contains so many Verkhovsky eponyms? Who was the initiator of Verkhovsky eponyms? He himself or somebody else? Well, Verkhovsky is the author of the book in question, so whether he branded his inventions his name or was advised or pushed to do so, he was aware about this self-eponymization. There are examples in history. Physician Jack Lips invented an intrauterine contraceptive device and called it so, Lips Loop. Engineer Seymour Cray designed the Cray supercomputer. Frankly, when I was a graduate student in 1989, I myself used existing Soviet patent law, which allowed the inventor to officially register his invention carrying his name. And I received a certificate on invention, Slavin's type. Today, patent law in Russia does not recommend using names in the invention title, though it does not forbid either. And so does US patent law, asking for a specific and descriptive invention title, not a personal name. The real honor, however, lies in having someone else bestow the tribute upon the author, having a messenger. The reason why so many eponyms could originate from one author and be self-introduced in this book can be assigned to ethnocentrism. In the beginning, education in Europe used to be universalist in character. Universal phenomena were explained in terms of a single coherent value system, generally from the point of view of religion or ideology. But then the interest in specific national characteristics arose during the Enlightenment and developed alongside the establishment of bourgeois societies in the 19th century, in parallel with the emergence of a universalist view of education. By the latter half of the 19th century, political power and public opinion have paved the way for education to become more national in character, for national identity to become stronger, and for the newly created traditions to be handed down in such a way as to appear almost everlasting. It seems that values such as national tradition and national characteristics pervaded all education, and as general principle in the mid-19th century. In countries where the creation of a new type of national identity became the order of the day, Germany and Italy, and as well in countries which sought their own national identity within a multinational state. After the Second World War, it seemed for some time that ethnocentrism would give place to several types of universalism in quick succession. First, mankind, then the free community of nations liberated from fascism became the ideal. Establishment of the United Nations and its specialized agencies. However, later in Eastern Europe, the idea of a socialist national community with a system of values assumed to be universally socialist in nature gained hegemony. And in the late 20th century, ethnocentrism gained strength. National identity and national differences became important once more in Eastern Europe, as well as in many other parts of the world. Ethnocentrism projected into history and literature, humanities first of all, but science education too. If ethnocentrism is still notable in Europe, one can imagine how especially strong it was in the Soviet Union, the country in the epoch where and when Verkhovsky lived and his book were published. In 1946, academician Kapitsa sent Stalin a letter in which he stressed that a great number of discoveries was anticipated in Russia. Now it's time to renovate the industry and to train specialists, he said. To do so successfully, one should believe in our own creative potential, Kapitsa said. Well, saying so, he was not the pioneer. Mendeleev, the inventor of the periodic system of elements, believed that the task is not to train engineers and scientists, but the task is that engineers and scientists, upon receiving their diplomas, remain Russian in all senses. If we imagine the atmosphere in the society at that time, Verkhovsky's book was published in 1959. No wonder that it contains 6 eponyms of his own as a manifestation of Russian creative potential embodied into specific scientific items. And probably it's not bad for the historians of science. Scientific knowledge is impersonal in the sense that its claim to truth must be assessed apart from its source. But at the same time, one should prevent this knowledge from sinking into anonymity, to preserve the collective memory of its origins. Eponymity not anonymity is the standard. The third question is how come that Verkhovsky eponyms vanished from Russian chemical usage? It can be, of course, that laboratory equipment since his time became more advanced, sophisticated, and replaced his inventions. There is also a described trend that eponyms, especially in analytical chemistry, became rare in the post-1960 period. There can also be another reason. As a rule, names to scientific achievements are not given by historians of science or even by individual scientists, but the community of practitioners. Also, names are rarely given, nor generally accepted, unless the messenger is remote in time and place, or both, from the scientist being honored. For this statement to be true, an eponym must not only be awarded on the basis of scientific merit or originality, but it must be perceived by practitioners as based on merit and not personal friendship, national affiliation, or the political pressure. Where these requirements met at the time of Verkhovsky eponyms, we don't know. Insufficient historical data and available sources to answer, but if they were not, it can be an explanation. Finally, the last but not the least question on this history is what are recommendations for chemistry teachers introducing eponyms at their lessons with principles of humanization and historicism in mind? Well, forgotten eponyms per se do not create an issue, so not to mention them is one way. There are a lot of other national eponyms to teach and educate. Alternatively, one can teach Verkhovsky eponyms despite them being forgotten, to revitalize interest to the national scientific history. But whether a teacher decides to teach Verkhovsky eponyms or to refrain from it, their history is a good example of science as a human endeavor, a cross-cutting concept present in many educational standards of the world. Thank you for your attention.
So much. Angela. So today, missed the time because after one bottle of vodka, broken hearted, bread and onion, nothing more, nothing more. I think that the opening part here is for you, ice breaking, because you are an ice. Breaking heart. So the intention was to break your eyes.
Oh my lord, send me that video. I'm gonna play for my family.
Send directly to Michelle.
And then I'm gonna tell them.
And tonight,
I could have been in
some
Russia.
minutes ago, yeah, our hypothesis was confirmed. Because she said, I cannot resist all elder people. I treat them so well. Yeah, she took care of our old lady in the chocolate factory, and yesterday,
I gave her money because she just looked so that she needed money.
But after, broken heart. Poor guy. He stayed there. Look. Vodka. So sad. So sad. So he had so much vodka. No, because the Russians drink so much vodka. Yeah. But as yesterday, someone broken his heart because he expected to have a lovely or warm night. But someone just broken his heart. They drank so much vodka.
Oh my lord. Okay. I need
Vodka
to know.
sociology.
Vincent is enough now.